Today we're going to look at solving one-step and two-step equations. We're going to start off with addition and subtraction one-step equation. First of all, write out the equation and then look at the side with the variable. Notice we're not looking at the 72, but everything on the side of the equal sign that has the variable, and we're going to look at what else is there and what we can do to isolate this x to get it all by itself. Looking at it, we see a 15, so we need to figure out how to get rid of that 15. So we're going to do that by undoing the 15, using that additive inverse to get rid of it. So what's the opposite of 15? Subtract 15. So we're going to subtract 15 from both sides. The opposite of 15 is negative 15. So when we do that, then we've zeroed it out and we've made it disappear. Now we've got x on this side all by itself. So we're going to follow through and bring that x down. When we subtract 72 minus 15, we end up with 57. So our solution is that the variable x equals 57. Make sure we're getting ready for algebra, so we want to get in the habit of putting our letters on the left, numbers on the right. Remember, little neater, letters on the left, numbers on the right. We're not done yet, though. We want to check and make sure we've done it correctly. So we're going to check our solution. When we check our solution, we're going to rewrite the equation in the same original format, except when it comes to x, we're going to replace it with our solution. So we have 15 plus, and instead of x, we're going to put our solution 57 equals 72. And when we check that out, 15 plus 57 does equal 72, so we found that we did it correctly. Let's try another one. Let's look at multiplication and division one-step equations. So looking at this equation, we have 21 equals 3 times x. Now I know a lot of you can do in your head 3 times what equals 21, but we're practicing the process to make sure we've got it easily and we can check and see if we're doing it correctly. So let's go through the steps. Again, we're going to undo to get the x by itself, our variable by itself. So we're going to undo the operation. Instead of 3 times x, what's the opposite of multiplication? That's right, it's division. So we're going to divide both sides by the coefficient, which happens to be 3. So 3x divided by 3, and over here 21 divided by 3. When we undo that, we then have 3 divided by 3, and we know that that's a form of 1. We've used the property of equality on both sides, and we've got our form of 1. That means we've isolated for x. So we have 21 divided by 3 is 7, and our x. But we want to get in the habit again of putting our letters on the left, numbers on the right. We're going to make it a little neater. So we have x equals 7. We're not done yet. We need to check our solution to make sure we've done it correctly. So we're going to put it in the same original format. Instead of 21 times 3x, we have 21 equals 3x. We have 21 equals 3 times 7 because we plugged it in, the 7 for x. Plug it in, plug it in. All right, now, indeed, 21 equals 21. Looks like we're correct. Let's take a look at killing fractions. I don't know too many people who like fractions, so this is a chance to kill them, and you won't even be arrested, have to do any jail time. We get to get rid of those puppies. The way we do that is we're going to multiply our fraction by the multiplicative inverse. Because if you remember, that multiplicative inverse says that when you multiply by the inverse, you get 1. So let's take a look at that. What's an inverse? Well, let's take a look at this gentleman, and we're going to find his inverse. Here he is, and there's his inverse, and here he is, and there's his inverse. This is for you, 24. There he is, and again, there's his inverse. We've inverted him. Getting a little bit dizzy here. So let's get back to numbers. 5 over 8 times, if we put the 8 on the bottom on the top, and the 5 on the top on the bottom, we found the inverse. When we multiply straight across, we get 40 over 40, and as we know, 40 divided by 40 is a form of 1. Move over, Arnold. You guys are quite the hero. You've killed fractions, you've annihilated coefficients, you've saved some babies. Let's try it in an equation. Oh, here's another form of killing a fraction. Sometimes it'll look like this. X divided by 2. So what do we do now? Well, we know that this x is just one x, and we usually don't write a coefficient of 1, but if you do, it's okay. So we have 1 over 2. The inverse is 2 over 1. So a couple of ways to look at it. One is you multiply by whatever the denominator is, or you can think about it as flipping it too. That will kill our fraction because 2 over 2 is a form of 1. X over 1 is x. So we're done. We've killed that fraction. Now let's take a look at it with an equation. Here we have 2/3 x equals 12. Well, we don't even need to look over here. We're going to take a look at this 2 over 3, and we want to kill that fraction. So we're going to kill it by multiplying both sides by the multiplicative inverse. That means we're going to multiply this by 3 over 2 and this side by 3 over 2. Sometimes students have trouble with looking at 12 times 3 divided by 2. So another thing they can do is they can give that 12 a 1 to see if that makes it easier to do. Well, we know that 3 times 2 is 6 and 2 times 3 is 6, and 6 over 6 is a form of 1. Also, we can cross cancel here, cross simplify. 2 over 2 is 1, 3 over 3 is 1. So now we're left with this right over here. I'm going to see if we can cross simplify, because I like to work with smaller numbers if we can. And indeed, 12 and 2 are both divisible by 2. So I'm going to divide 12 by 2 and get 6, and 2 divided by 2 is 1. Now I'm working with smaller numbers. So we have x equals 6 times 3, which gives us 18. Our next step is to check our solution and see if it works. So we have 2/3 times 18, and I gave him a friend to make it easier for me, equals 12. I'm going to look across here. Can I cross simplify? Yes. Both 18 and 3 are divisible by 3. So 3 divided by 3 is 1. 18 divided by 3 is 6. Oops, went too far. So 2 times 6 is 12. And 12. So we've got it. Yay! We've been heroes. We've killed those fractions. We've annihilated coefficients. We've saved babies. It is time to become, dun 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 dun, a superhero. And what do superheroes always do first? They save the babies. And what kind of math do babies do? They add and they subtract. That means when we have two-step equations, we're going to look for our babies first and save them. So looking at this equation, we have 4x plus 5 equals 33. Now I'm not even going to look over here. I'm going to focus over on the side with the variable. We have 4x plus 5. Here's our baby. So we need to get rid of it. And what is the opposite of plus 5? Minus 5. Or you can think positive 5, negative 5. So what we need to do to both sides is to isolate that variable by getting rid of that 5. So we're going to subtract 5 on both sides, and we've zeroed that out. That gives us 4x equals 28, because we're always bringing our equation down. Now we have a coefficient, so we need to annihilate this coefficient to get the x truly by itself. So we're going to divide both sides by the coefficient of 4. When we divide both sides by 4, it will give us a form of 1 over on the left side. So we have x equals, and 28 divided by 4 is 7. Once again, we're going to check our work and replace it with the original equation, which was 4 times 7. So we have 4 times x because our 7, because our solution was 7, and then we're going to add 5 equals 33. So 28 plus 5 is 33, and 33 is 33. So whether you're doing a two-step equation with division or a fraction or multiplication, you do it the same way. The most important thing is to check and make sure you save those babies first. So remember, get those babies away from the variables before you do anything else. keep those babies safe.